We have a test this week, and so there are a few things that we haven't covered in a while, so that's what we're going to be looking at today. And so as you see on the screen, the first thing that is highlighted is the Pythagorean theorem, a squared plus b squared equals c squared. And my question is, what do all the letters mean? Formulas do no good if we do not know how to use them. So we're going to talk about that. So in the Pythagorean theorem equation, we have to remember that the Pythagorean theorem only works on right triangles. So if it's not a right triangle, we have to use something else, not the Pythagorean theorem. And so each of these letters is assigned to a side of the triangle. So 3 letters, 3 sides makes sense. So this A is one of the A and B, I guess I should say. A and B are both a leg of the triangle. And if you notice here, just a little, that makes a nice little L. So A and B can go on the legs. And then the most important one to place is our letter C, which is the hypotenuse of the triangle. It is always opposite of the right angle, and it has to be the longest side. And it doesn't matter which way it's turned, C is always across from the right angle. So we just covered that, what shape can you use them on, and it's only right triangles. And one of the things about triangles is that we have to determine if it is a right triangle, because then we can use the Pythagorean theorem to solve for the missing sides. So if a squared plus b squared equals c squared, then what? It means that it is a right triangle. So let's go ahead and ask a question. So students were asked to determine which of the given triangles are right triangles. 3 students were discussing their answers as shown below. So DeAndre, Anna, and Tommy are all saying different things about these different triangles here. So in order to figure out which one's right, which student is right, we have to take our 3 triangles and determine whether they are right triangles or not. So if each of these is claiming, I'm going to go ahead and add a right angle into each of these. So knowing that in order for it to be a right triangle, the longest side has to be across from the right angle. So I'm identifying each of these, the largest numbers in each of these. So what I can do is say 4.5 squared plus 6 squared equals 7.5 squared. I can say 2 squared plus 3 squared equals 3.5 squared. And the last one, 2 squared plus 3.75 squared equals 4.25 squared. So what you'll want to do is get your calculator out and tell me which of these students is correct. They are all giving different ideas as to why and which ones are right triangles. So go ahead and take a moment, pause the video, and figure that out. So now I would like you to pause and observe these 2 examples. We have example 1 and example 2. And as we just showed before, we're substituting numbers in for the side lengths of the triangle. In these cases, there is no triangle that we see. So what is the difference between these 2 processes of solving for one of the missing sides of the triangle? Okay. And if you'll notice, this one here has a C missing, and this one has a B missing. And what is the difference in the process moving from there? So what I'm going to do is I'm going to probably solve one of these, and then I will let you pause and work on the other one. So I'm going to use this first one up here in the corner, use this right triangle here. So we're solving for the missing side, which is the hypotenuse. So what I'm going to do is write my formula here, and then I'm going to substitute what I know, just remembering that the side lengths, the legs of the triangle, are interchangeable, so it does not matter if 6 or 8 is A or B. So as I simplify, I'm going to go ahead and say 6 squared. This is going to be 36 plus 64 equals C squared. So from here, we can add up these. So we have 100 equals C squared. And then remembering that in order to unsquare something, specifically this C, because we're being asked for just the length of C, not C squared, we need to take the square root of both sides, which gives us a side length of 10. And that is the answer. So go ahead and take a moment and solve for these other two examples. So now I want to work one that has a missing leg rather than the hypotenuse, because you notice here we are given the hypotenuse, which is 13. So I'm going to still use my same formula, a squared plus b squared equals c squared. But this time when I substitute, I'm going to substitute the 5 squared for a. I'm going to keep my b squared, and that's going to equal 13 squared. So now I can simplify that. So 5 squared is 25 plus b squared equals 169. So from here, you notice that we have a variable and a constant on the left side of the equation. So we're going to have to use an inverse operation here, and we're going to have to subtract. On the left, that becomes 0, and we're left with b squared equals 169 minus 25, which gives us 144, which is nice because 144 is a perfect square. So in order to find the length of b, we have to take the square root of both sides, which gives us the square root of b squared is b equals, and the square root of 144 is 12. So that is the number that would go on that triangle there. So take a moment and solve for that other one. So here we have what's the length of the hypotenuse, what's the slope of each side of the triangle. So sometimes you will see a right triangle placed on a coordinate grid. So there are multiple things that we know we can do now that we've learned about slope and length. So on a coordinate grid, we can easily count the length of our side. 1, 2, 3, 4, 5, and 6. So we have a length of 6 here, and on the bottom we have 1, 2, 3, 4, 5, 6. So we have 6 on each side, but we cannot properly count these because the length of this length here cutting across, even though it looks like it's right in half, we cannot consider that as 1. So what we're going to need to do is use the Pythagorean theorem in order to solve for this. So we would go a squared plus b squared equals c squared, and then we got 6 squared plus 6 squared equals c squared. And then we're going to go ahead and simplify from there. We have 36 plus 36 equals c squared. 36 plus 36 is going to be 72, I believe. So we have 72 equals c squared. And again, we're just looking for the length of c. We're not looking for c squared. So we're going to have to take the square root of both sides. And that will simplify to 8.48. So I'm going to go ahead and round that to 8.5. So that gives us the length. So this here, the length is c, 8.5. But the next question is, what is the slope of each side of the triangle? So in this case, there are two things that we can do. First, since it's on a coordinate grid, I'm going to go ahead and erase that line. We can use the rise over run method. which would say we have these pretty points here that are located on the line, which creates our hypotenuse. So we can count our rise, which would be 1, and our run, which would be -1, which simplifies to -1. So we could do that. And we could also use the coordinate pairs. So remembering our slope formula, we could pull out the coordinate pairs of 2 points. So we could do, this would be like -2, 0, and this would be -1, -1, and we could do that into our slope formula. So we would have y2 -1 minus 0 over -1 minus -2. So that would leave us at -1 over 1. So we see we get the same answer. So those are 2 ways that you could find the slope of this line. So go ahead and take that into consideration. There will be a test question like this, so be aware. I'm going to pause on these ones here. So remembering that when things are placed on the coordinate grid, as you see here, in order to find, saying if square B is 144 feet squared and C is 169 feet squared, what is the area of square A? So remembering that that is looking for the entire area of this square, not just the side length. And so you can do that by taking the square root of both sides, remembering that it's still a squared plus b squared equals c squared, but c and b, these are already squared, so we're just looking for a. So we can say a squared plus 144 equals 169, and then we are able to find what a squared is, which would be the area, or we can take the square root to just find the side length of a. And there are 2 questions like this that you'll want to look at. And then we have our next formula, which is simple interest. We have formulas do no good again, so we're going to review what each of these letters mean. So in our simple interest formula, we have the interest earned or paid. Then we have our principal amount, our rate, which has to be in a decimal form, and our time, which has to be in years. Okay, so answer this question there. And so I'm going to go ahead and I equals PRT. So from here, each of our letters is going to be substituted. So a $1,200 bond earns a 3% simple interest per year on its purchase price. What is the amount of interest earned after 15 months? So there are 2 things that we're going to need to do. So before we put our 3% in for our rate, we're going to have to divide that number by 100, which will give us 0.03. And then our time has to be in years, so we're going to have to divide that by 12, which will give us 1.25 before we substitute. So we can then multiply all of those together. 1,200 times 0.03 times 1.25, and that gives us $45 interest earned on that bond after 15 months. Okay, so just to take into account, if they said how much is the total bond worth, in order to find the total amount, you're going to have to take your interest earned and you're going to have to add that back to your principal. So that's going to be the 45 plus the 1,200 original, and that will give you your total amount of the bond after that 15 months, because $45 is just the interest. So go ahead and pause the video and look at this one. And our last formula to review today is the compound interest formula. And let's go ahead and look here. So we have here, this is going to be our total amount, or total balance. This is still going to be our principal amount. We have our rate. This is literally just means 1. It's just a 1. It's in the formula. And our time, again, in years. So there we have it. And if A is the total amount, how do we calculate the interest earned? So when we solve and when things are compounded annually, we're going to get a total amount. But that does not tell us how much interest was earned on that amount. So what you'll have to do is take your amount. So in order to find the interest earned, you take your total amount that you just calculated for, and then you're going to have to subtract that principal amount to figure out how much of that sum is just interest. So we have Anna opened a savings account with a principal balance of $2,250 and will not make any additional deposits or withdrawals. The account earns a rate of 2.4% interest compounded annually. What is the total amount Anna will have in her account after 6 years? So I wish I would have done this on the last one, but just knowing that those are the missing letters in our formula. So those are the ones we have to extract from our equation, and it makes it a little bit easier when we're going to substitute. So this here, the rate, we're going to need to divide by 100, which gives us 0.024. So before we put that into our formula, we need to make sure it's in the correct form. So here we have A equals 2,250 parentheses 1 plus 0.024 raised to the 6th power, and making sure that this is an exponent and not just a number being multiplied. And then we're going to go ahead and just put that right in your calculator, 2,250 parentheses 1 plus 0.024 raised to the, with the caret button, 6th power, and that gives us a total amount of $2,594.07. So that is how much she will have in her account after 6 years. So this isn't in the question, but if I said how much interest will Anna have, or how much interest did Anna gain off of her initial amount she put in. So what I'm going to have to do is take my total amount, $2,594.07, and I'm going to have to subtract that principal amount, which was $2,250, and that is going to be a total of $344.07. So this here is the interest that she gained on her account that was compounded annually. So it's a little bit backwards of simple interest because you're having to subtract at the end rather than add it back. But I'm going to pause on this next one. Take a moment and see if you can figure that one out. And I think that is the last one. So good luck. Make sure to do this because there will be test questions like this, and I know we haven't covered it in a while.